Okay, so on 3-6, we are going to want to color code things, because if we do not color code things, life is going to get kind of crazy.
My name is Katie Keisha. What? You don't like my leaf?
Okay, we're talking about multiplying matrices now. Okay, now when you add matrices, they have to be the same to add them, correct?
Yes.
Okay, when you multiply, it's not that case. We're gonna talk about what has to happen in order to be able to multiply. Okay? In order to multiply, the middle portion, so if I have a 3x2 matrix, okay? I can multiply a 3x2 matrix with a 2x4 matrix, because this and this are the same. So it's like the outer, the end and the beginning have to be the same of what you're multiplying together. Now, that means that you're going to end up getting a 3x4 when you multiply them together. You get what's left over. Okay, so the middles, if you put them in line, the middles have to be the same numbers. And then the outsides is what you're left with. Okay? So we are going to, first of all, have to identify if you can multiply matrices together. Can I multiply a 4x3 and a 3x2 together? Yes. And then, because the 3's would be in the middle. And what would I get?
4 times 2.
A 4x2. A 4x2. Can I multiply a 3x4 and a 3x2 together? No, so you just say not possible if that happens.
So it's
Okay.
either defined or impossible.
Yes, it's either you can do it or you can't. Okay, can you do a 5x2 and a 2x2?
Yes.
And what do you end up getting?
5
A 5x2. Can you do a 3x2 and a 3x2? No, but can I add a 3x2 and a 3x2?
Yes.
Yes, okay. When you multiply matrices together, you have a lot, I mean, it's a process, okay? There is no short route to it. To get this first spot, just this first spot, you have to multiply A times E, so you're going row by column. You're multiplying a row by a column. I multiply A times E, and I add it to B times G to get that first spot. Row by column. You multiply the row by the column. Okay? So A times E plus B times G gives me that first spot. This next spot, row times column. A times F plus B times H gives me that spot. For this next one, row times column. C times E plus D times G gives me that spot. For the last spot, row times column. C times F plus D times H. Okay, you go row times column, row times column. A lot of times I do mine in a bunch of different colors so that I can keep it straight. Like I'll make all my rows in one color, you know, and maybe the columns on the other, or circle them so I know what's going on. Can I multiply these two together? What size is this right here? 2 by 2, and this is a, so what can I multiply this together? Yes, and what am I gonna get out? Okay, so let's look at multiplying these together. 1, 4, 3, -2. And then I'm gonna multiply them together like this. 5, -7, 9, 6. Okay. To get this first spot right here, I need to multiply this row by this column. 1 times 5 is plus 4 times 9, which is, what's 4 times 36?
36.
Okay? To get this part right here, okay, I have to multiply this row by this column. What's 1 times -7? Plus 4 times 6, 24. Okay? To get this one right here, I have to take this row and multiply it by this column, 3 times 5, plus negative 2 times 9, negative 18. To get this part right here, I have to take this row and multiply it by this column, 3 times negative 7, plus negative 2 times 6, negative 12. So my solution comes out to be, what's 5 plus 36?
41.
What's negative 7 and 24 together?
17.
17. What's 15 and negative 18? Negative 3. And what's negative 21 and negative 12? Negative 33. There's my new matrix when I multiply them together. Okay, you have to take your time on this, and you have to show me all the steps. If you don't, I guarantee you'll mess up someplace along the line. Okay, that's a pretty simple one because it's only a 2 by 2 and a 2 by 2. Okay, when they're not the same size, they get a little bit trickier. Okay, so here, they want us to multiply, well, first they want us to add B and C together and then multiply it by A. Do you see that? Okay, that's what that's telling me. Over here, this one's telling me multiply A and B and then add it to the multiplication of A and C. Okay, well, let's see if we can do this first. This is a, what shape is this? 3 by 2, and these are 2 by 2s. So can you multiply a 3 by 2 and a 2 by 2 together? Yes, and you're gonna get what out? 3 by 2, okay? So that means we can go ahead and set this up. I'm gonna say 4, 3, well, maybe if I can write. Actually, let me do it over here so I have more space. Okay, let's go like this. We're gonna go 4, 3, negative 1, negative 2, 2, and 0, okay? And we're multiplying that, right? By B plus C, and B is negative 3, 0, 1, negative 2. And C is 1, 4, negative 3, negative 1. Okay, so you have to do order of operations first, yes? So let's add these together before we multiply. I'm gonna recopy this down here. And let's go ahead and just add these together, oops, so we can multiply them. It's over there. Negative 3 plus 1. Negative 3 and 1 is what? Negative 2. 0 and 4 is, I got it. 1 and negative 3. And negative 2 and negative 1. Now we can multiply these together. Okay? Now, to multiply them together, we have to go row by column. Okay? We know we're gonna get a 3 by 2. So for this first spot, we have to do row by column. 4 times negative 2 plus 3 times negative 2. Okay? For this next spot, right, we're gonna go row by column again. Row, column. 4 times 4 plus 3 times negative 3. For this spot, we're gonna go row by column. Row, column. -1 and -2 multiplied together. Plus -2 and -2 multiplied together. 4. Now to this spot. Row, column. -1 times 4. -4 plus -2 times -3. 6. And last but not least, for this spot, we go row by column. 2 times -2, -4 plus 0 times -2, 0. And then for the last spot, row, column. 2 times 4 plus 0 times -3. So then we just add these together and we get our matrices. -8 and -6 together is negative 16 plus -9 should be 7, yes. 4 and 2 is 6. -4 and 6 is 2. -4 and 0 is -4, and 8 and 0 is 8, and there is my matrix after I did all of that lovely work. What? It felt long? It is long. It's gonna take you time.
Can we have a 4 over 3? Can we have like 6 over 5?
We're not gonna do any bigger than 3 by 3s. So, don't stress about that. Nothing will get, we're not gonna do anything bigger than a 3 by 3. You would want a graphing calculator to do something larger than a 3 by 3, just trust me on that. Okay? So that is an example of how you do something like that, okay? What about AB plus AC? Can we multiply A and B together? Can you multiply A and C together? Yes. So we would multiply both of those together and then just add them because they would be the same thing. They would be 3 by 2s, okay? We're not gonna spend time to do that right now. Okay. So when you are multiplying matrices, okay, order does matter, okay? Because remember, we can only multiply matrices that have the same middles, so order matters. So I can't flip it around, okay, because it might not work. Because if I have a 3 by 2, let's say I have a 3 by 2, and I want to multiply it to a 2 by 4, okay? I can do it in that order, yes? But if I said a 2 by 4 times a 3 by 2, can I do it in that order? No. So when you are writing this stuff out, order matters. It is very important to realize that. You have to follow exactly what it's saying in order for it to work or not. Okay. Cost matrices, okay? Matrix multiplication is very useful in business. It's used all the time in business. So if you're going into business, know that you'll take a class that involves this, okay? Business applications, because an inventory matrix, when multiplied by a cost per item matrix, results in a total cost matrix. So they'll take inventory of something, multiplied by the cost, and then tell you what your overall cost is of the object. I don't know why these are like so large today. Okay. So, 2 hockey teams submit equipment list for the season as shown. Each stick costs $60, each puck costs $2, and each uniform costs $35. Use matrix multiplication to find the total cost of equipment for each team. How could we do that? How can you set that up? No, you only need 2 matrices.
One stick.
One for women's, one for men's.
No, I'm not making 2 separate for women's and men's. I'm going to make a women's and men's matrix together. So my rows will be women's, men's. My columns will be what?
Oh, six.
Sticks and
Sticks, pucks, and uniforms. So if you do a matrix that's 14, 30, 18, 16, 25, 20, okay? If you read it this way, it's women's, men's, yes? This is sticks, pucks, uniforms, okay? What is the other matrix I need then? Because cost doesn't change for them, yes? So cost is gonna go like this, okay? And your cost of sticks is 62 for uniform, 2 for pucks, and then 35. I was like, man, those are cheap uniforms. Now, what size is this?
2 by 3.
2 by 3. What size is this?
1 by 1.
Rows.
Oh, 3 by 4.
3 by 1. 3 rows still. Row 1, row 2, row 3. So this is a 2 by 3, yes? 2 by 3. This is a 3 by, so can you multiply them together?
Yes.
And what are you gonna get?
2 by 1.
A 2 by 1. Okay? So when I multiply these, right, I do row by column. Okay? So what is 14 times 60? 14 times 60 is 840. Plus 30 times 2, which is 60, right? Plus 35 times 18, oops, see if I press 35, good, and you get 630, okay? Now, for this down here, you're doing row times column. So 16 times 60 is 960. And 25 times 2 is 50. And 20 times 35 is 700. And we were looking for the total cost, right? Well, all of that is money added up. So 840 plus 60 plus 630 gives me 1530. Okay, 1530. And 960 plus 50 plus 700 gives me 1710. Look at this matrix. It is a 2 by 1. Women cost $1,530 for their order, and men's order cost $1,710. Okay? That is the end. That's what you're working on tonight. Matrix multiplication. Take your time to do it.